Hello students. Now today we'll discuss another reaction, and that one is diazotization reaction. See what happens when aromatic primary amine are treated with HNO2, means nitrous acid, at 0 to 5 degree Celsius temperature. Here diazonium salt is formed. So this conversion of aromatic primary amine to diazonium salt by treating with HNO2 at 0 to 5 degrees Celsius, this reaction is known as diazotization reaction. Remember here, the temperature condition is very much important. The diazonium salt obtained from the aromatic primary amine is stable only in this range of temperature. If the temperature will exceed then 5 degrees Celsius, means let this one is your aromatic primary amine, and this reacts with HNO2, but now the reaction occurs at temperature greater than 278 Kelvin, or you can say or 5 degrees Celsius temperature. Then in this situation, instead of diazonium salt, we will get phenol along with removal of nitrogen. So remember that diazonium salts, even which are obtained from the aromatic primary amine, they are stable only in the range of temperature 0 to 5 degree. As the temperature exceeds then 5, so instead of getting diazonium salt, the aromatic primary amine will form what? Phenol. See. Now, how to write this reaction? See, one thing more here. This nitrous acid, which is used as a reactant in this diazotization reaction, this one is also very unstable. Means it's not possible to store the nitrous acid, and that's why in all such reactions where HNO2 is required, it is prepared within the reacting vessel by the reaction of NaNO2 and HCl or H2SO4. So this nitrous acid in all such reactions where this one acts as a reactant is prepared within the reacting vessel by the reaction of NaNO2 and HCl or NaNO2 and H2SO4. See, how to write the reaction? Let here, this is our aromatic primary amine and is treated with HNO2. See, what actually happens, we used to take NaNO2 and HCl. Now, as a result here, we will get HNO2 and along with NaCl will set. The reaction occurs at 0 to 5 degrees Celsius. See what happens? These two hydrogens comes out with the electronegative oxygen, and this hydrogen also comes out with the OH. The two water molecules set free. Now both nitrogen will combine together, and here you will get N2. At this nitrogen there will be a positive charge. Now this Cl minus will form bond with it. This one is known as benzene diazonium chloride. See here, azo means nitrogen. As there are two nitrogens, that's why it is diazo. And since in here the nitrogen bears positive charge, and that's why the suffix "-ium" is used here. So the name becomes of this salt is benzene diazonium chloride. Is it clear? And this reaction of conversion of aromatic primary amine to diazonium salt, this reaction is diazotization reaction. Now we'll discuss the mechanism of the reaction, how actually the reaction occurs. See here, NaNO2, this reacts with HCl and forms HNO2 plus NaCl. Remember one point that the oxo acids of the nitrogen are not very stable, and they usually form in the form of their salt. See, same with, that's why the nitrous acid exists in the form of the nitrite salt. It is sodium nitrite. So HNO2 is obtained here. Now the HNO2 this reacts with the H plus, or you can see that this HNO2 molecule further gets protonated. HCl will furnish the proton, so the H plus will attack over the, or the electron pair of the oxygen of OH bond are donated to the proton furnished by the HCl, and thereafter at this oxygen now, after protonation, one more hydrogen will form bond with it. As oxygen has donated electron pair, will become electron deficient and positive charged. Now, in order to compensate the positive charge of the oxygen, the electron pair of this NO bond shifted over the oxygen, and the water molecule will set free. Here the remaining species is this. Here, as nitrogen has lost its electron, so there will be a positive charge. This type of ion will get, this one is nitrosonium ion will be formed. Now, the another reactant was, it was aromatic amine. Here nitrogen was having a lone pair. Now this nitrosonium ion as is electron deficient. Here nitrogen is having a lone pair, so nitrogen will donate its electron pair to the electron deficient nitrogen of the nitrosonium ion. See, At this nitrogen, already there were two hydrogens. Now nitrogen will form bond with the nitrogen, and the positive charge of the nitrogen will be compensated, but this nitrogen has donated electron pair, so will become now electron deficient. Then, in order to compensate the deficiency of the nitrogen, the electron pair of the NH bond shifted over the nitrogen, making free hydrogen as proton, and we will get, see here, nitrogen, there's the hydrogen, lone pair will come back, here nitrogen, there's the one lone pair, there's a double bond. This type of compound is obtained, which is our nitrosoamine. And now this nitrosoamine will get protonated. See, in the medium, proton sets free. Now this proton will attack over the oxygen of the nitrosoamine. Now only one pair of electron will left over oxygen. The proton will form bond with this oxygen, and because oxygen has donated electron pair, so will become electron deficient. Now to compensate its positive charge, the electron pair of this pi bond, NO pi bond, shifted over the oxygen. This results that the nitrogen will become electron deficient, positive charge. To compensate the deficiency of this nitrogen, the electron pair of this NH bond shifted in between the two nitrogens, making free this hydrogen as proton, and thereafter we'll get here what? Nitrogen. As the two electron comes in between the two nitrogens, double bond will form here, and as the electron pair of NO bond shifted over oxygen, single bond will remain here. Over this oxygen there is a hydrogen, and its electron deficiency will be compensated. We'll get this type of compound. Now this compound further undergoes protonation because protons are here. So the oxygen will donate its lone pair to the H plus, here is the nitrogen, double bond, nitrogen, and at this oxygen already there was one hydrogen, one more hydrogen will form bond with it. Now only one pair of electron will left over oxygen, and now oxygen will acquire positive charge. Thereafter, in order to compensate the positive charge of the oxygen, the electron pair of the NO bond shifted over the oxygen, and the water molecule will set free, and here the remaining species is this. In this remaining species, as the nitrogen has lost electron, so this nitrogen will have positive charge, although it is having a one pair of electron. The ion thus obtained, this one is called diazonium ion. This diazonium ion, here there is a resonance. In order to compensate the positive charge of the carbon in this nitrogen, the electron pair of the nitrogen will shift in between the two nitrogens. And then there will be a triple bond between the two nitrogens. As this nitrogen has donated electron pair, will become electron deficient and will have positive charge. In order to compensate its positive charge, the electron pair will shift over the nitrogen. You will get this type of structure. These are the two structures, resonating structures. Actual structure is none of these. Actually, in this diazonium ion, in between the two nitrogens, there is neither double bond nor triple bond. The bond in between the two nitrogens is in between the double and triple bond, and both the nitrogens are having positive charge. So here it is denoted or mentioned here in between the two nitrogens. This one is the hybrid, resonance hybrid. And now the Cl minus, in order to make this diazonium ion stable, so the Cl minus ion which are there in the medium, after setting free the H plus, will form bond, ionic bond with the diazonium salt, and this one is known as benzene diazonium chloride. See, here in between the two nitrogens, neither there is a double nor triple bond, and that's why it can be written as N2. Is it clear? So this was the mechanism of the diazotization reaction.